Well, we've talked about how we add polynomials, how we subtract polynomials, how we multiply polynomials. So finally we're down to how we divide polynomials. And we'll look at a couple of examples here and begin to get the hang of that. So here's a pretty long-looking division problem. So what we have is a polynomial on the top. What's the degree of the top? 5. What's the degree of the bottom? 2. And what we have is a polynomial of degree 4. I'm sorry, a fourth. Here, let me say it again. This is a 5th degree polynomial with 4 terms. Say it again. It's a 5th degree polynomial with 4 terms. We're dividing by a monomial. So all we do here, this is simple, is just divide each term by 3x squared. So we get 3x cubed minus 2x squared plus 6x minus 7. So there's a pretty simple problem. If we do another one like that, let me write it out and then we'll go through it. Okay, so here again, what we have is a 3rd degree polynomial with 4 terms being divided by a monomial. And so we divide term by term, and what we get is 4x minus 2 minus 6 over x plus 3 over x squared. Okay, so here's a little bit more realistic type of division problem where we're dividing a 3rd degree polynomial with 4 terms by a binomial. Now, it's a lot like the long division that you learned back when you were in elementary school. And the way we begin, the way we continue, is we take the first term here and divide it into the first term here. So if we divide x into 6x cubed, we get 6x squared. And then, just like with long division, we multiply. So 6x squared times x gives us the 6x cubed. And then we have 6x squared times minus 2, and that gives us minus 12x squared. And what do we do now? We subtract. And just to make sure that we really see that it's subtraction, I like to put that sign way out here. 6x cubed minus 6x cubed is 0. Minus 2x squared minus a minus 12x squared is 10x squared. Now what do you do in long division? You bring down the next term. And so I bring down plus 4x. And I repeat, which means I take x and divide it into 10x squared. And if I do that, I get plus 10x. And then I do exactly what I did before, is I multiply. And I get 10x squared minus 20x, and I subtract. And I get 24x, bring down the minus 1, and repeat. X goes into 24x, 24 times, multiply, 24x minus 48, subtract, and I get 47. So 47 is my remainder, and then I rewrite this as 47 over x minus 2. And there is my answer. So it's really just one type of operation repeated 3-4 times. One of the things to point out is that it's very important to write these in descending powers of x. Let's look at one more example. So this isn't written the way that we wrote the previous one, and we always want to do write them in that way. So it's going to be x plus 3 divided into, now here we want to take a second and think. Remember we said that we want to write the polynomial we're dividing into in descending powers. Well, these are not descending powers. And if you look a little bit more closely, you realize that if we started with an x cubed term, we don't have an x squared term. And we have to always keep track of all of the terms. So in other words, we need to write that thing as 2x cubed plus 0x squared minus 4x plus 42. And so we've got to make sure that we account for all the terms. So now we can go ahead and do our division, and we divide x into 2x cubed, and we get 2x squared. We multiply, and we get 2x cubed plus 6x squared. We subtract minus 6x squared, bring down the minus 4x, and we repeat. So we divide x into minus 6x squared, and we get minus 6x. We multiply minus 6x squared minus 18x. We subtract. We get 14x plus 42. We divide x into 14x, and it goes 14 times. We multiply, we get 14x, and check it out, we get 42, which is really nice, so there's no remainder, and so that means that it goes in evenly, and this is our final answer. Alright, so that's all she wrote about division, and I'll see you next time. Hope you enjoyed it.